Hello everyone. Today we are going to learn about estimating program runtime. A real-time program is defined as a program for which the correctness of operation depends on the logical results of the computation and the time at which the results are produced. In general, there are three types of programming: first one sequential and multitasking and real-time. Estimating program runtime depends on following factors. First one, source code. Source code that is carefully turned and optimized takes less time to execute. Then compiler. It maps source level code into a machine level program. Machine architecture. Executing program may require much interaction between the processor and the memory and input output devices. Then operating system. Operating system determines such issues as task scheduling and memory management. Both have major impact on memory management. Then analysis of source code. Here consider the following code: A equal to B into C, B minus D plus E, B is equal to D plus E, D is equal to E minus F. This is straight line code. The total execution time is given by summation of I is equal to 1 to 3 T execution limited execution Li. Okay, where T execution is the time needed to execute limited. Seriya. Execution time analysis is any structured method or tool applied to the problem of obtaining information about the execution time of a program or part of a program. The fundamental problem that the timing analysis has to deal with is the following: the execution time of a typical program is not a fixed constant but rather varies with different probability of occurrence across a range of times. It's the first one, schematic of timing estimation system. Here first one, preprocessor, processor, time schema, code prediction, architecture analyzer, loop bounds and producer timer. It is a block diagram of time estimation system. Preprocessor produces compiled assembly language code versus analyze input source program. Procedure timer maintain a table of procedures and their execution times. The loop bounds module obtains bounds on the number of iterations for the various loops in the system. The time schema is independent of the system. It depends only on the language. Code prediction module does this by using the code generated by the preprocessor and using the architecture analyzer to include the influence of the architecture. Accounting for pipelining. Pipelining is the ability to overlap execution of different instructions at the same time. In a two-stage pipeline, you break down a task into two sub-tasks and execute them in pipeline. Let's say each stage takes one cycle to complete. That means in a two-stage pipeline, each task will take 2 cycles to complete, known as latency. An instruction has a number of stages. The various stages can be worked on simultaneously through various blocks of production. This is a pipeline. This process is also referred as instruction pipeline. The pipeline of two independent stages: fetch the instruction and execution instruction. The first stage fetches an instruction and buffer it. It is a pipeline of two independent stages. Here the fetch and here is the execution. Then next one is the result. It is a two independent stages. While the second stage is executing the instruction, the first stage takes advantage of any unused memory cycles to fetch and buffer the next instruction. This process will speed up instruction execution. Several factors serve to limit the pipeline performance. If the 6 stages are not of equal duration, there will be some waiting involved at various pipeline stages. Another difficulty is the condition branch instruction or the unpredictable event is an interrupt. Other problem arise that the memory conflicts could occur. So the system must contain a logic to account for the type of conflict. Thank you.